4.2 Basic Differentiation Rules. So I know this section is also called Rates of Change, but due to just the fact this is a bigger section rather, I decided to save rates of change and velocity for another time. But for this video, we'll talk about some basic differentiation rules. This section will probably make you not so thrilled with me. Not because it's hard, because it makes what you did in the last section a lot easier. A lot of you will be listening to this video and be like, "Why didn't Mr. Barton tell me about this first?" Well, the main reason why I didn't tell you about this first is because it's important to know why derivatives come from limits. Okay, so it's important for you to be able to calculate that so you know where they came from. Now we're going to show you some shortcuts to make our lives a little bit easier. So we're going to start with the constant rule for variation, or differentiation. I don't know why I said variation. Differentiation. So let's change that to differentiation. Cool. So what is this rule? Well, anytime we have a constant function called c, and for the record, derivatives can be written many ways. One can be d over dx. That's one way to say we're finding derivative of some. So we're finding the derivative of a constant c. It's always going to be equal to 0. Okay? Derivative of constant is always 0 if c is a real number. Okay? So no matter what it is, that's what it is. There's a proof in your book on page 273. If you want to look at it, go for it, have at it. We'll do a quick example. So let's say we have the function y equals 7. We can say its derivative is d, and one way of saying derivative is dy over dx is equal to 0. If we have f of x is equal to -2, we can say f prime of x is equal to 0. We could do this all day, right, with different constants, different numbers. The derivative of it will always be 0. And now the power rule for differentiation. Let's say n is a rational number, and let's say we have the function f of x equals x to the n. Well, this is differentiable and when we find the derivative of d over dx of x to the n, what we do is bring that exponent up front and then subtract 1 from the exponent. Okay? So we bring that exponent up front and then subtract 1 from wherever the exponent is currently. Now for some examples, let's say we have f of x is equal to x to the 4th. Well, the derivative, as you can see, n is equal to 4, so the 4 is going to go up front, and we're going to subtract 1 with the exponent, so it would be 4x to the 3rd will be its derivative. Next, let's do g of x is equal to x to the 1/2, or the square root of x, whichever one I'm giving you, right? Because the square root is like saying 1/2 power. So find a derivative, bring that exponent up front, and then we subtract 1 from the exponent, so 1/2 minus 1 is -1/2. One way to write this a little nicer would be 1 over 2x to the 1/2, because all we did was we threw that x to the -1/2 and put it on the denominator. Okay? Next, we are going to find the slope of the graph of f of x equals x to the 3rd at the following values, at x equal to -1 and x equal to 1. So remember, slope, anytime you hear us asking for slope now, you should be thinking about finding the derivative, right? Because that's one of the applications of derivatives, is finding the slope of a value. So let's find what f prime of x is equal to. That's bring the 3 up front, subtract 1 from the exponent, so it would be 3x squared. So now we need to find out what it would be at f prime of -1, which is 3 times -1 to the 2nd. -1 to the 2nd is 1. 1 times 3 is 3. So it would be 3 at that value. And then at 1, throw 1 in there, and it'll be the same thing. It'll be 3 as well. Okay? Next, we need to find the equation of the tangent line of the graph of f of x equals x squared when x is equal to 3. It's important to note we need to find what the y value is at x equal to 3 for the original. So we put 3 in, 3 squared is 9, so 3 comma 9 is going to be the point at which we're trying to find the tangent line, right? So we have the point, now we need to find the slope, okay? So how are we going to find the slope? Well, of course, you probably guessed it, it's finding the derivative. So, derivative, boom, 2x. F prime of x equal to 2x. So we did that. Now we plug in 3 in for x. So we 2 times 3, which is going to be 6. So the slope's 6, and we're going to put that into our point slope form that you hopefully remember. That's why we do this stuff in the beginning of the year, right? So we have the point 3 comma 9, and we have a slope of 6. So we have that. And then distribute, and then add 9, you're going to get y equals 6x minus 9. That is the equation of your tangent line. So this is called the constant multiple rule. Okay, so if I had a number in front of my x squared or x cubed or whatever is my function, right? That number is going to stay the same. Okay, it's going to still be there. You might have to multiply by a number, but it's still going to be there. Okay, so you just find the derivative of the function, and whatever number you're multiplying the whole function by, it's still going to be there. Okay, which is why it's called the constant multiple rule. That's only whenever c is real and f of x is differentiable. We have two quick examples right here. Y equals negative 5 over x, negative 5x over 6. So negative 5 over 6 is the constant, right? And the derivative of x is just going to be x to 0, which is just 1. So your answer is just going to be, I don't need an equal sign right there. I need a y prime. Another way to write your derivative is equal to negative 5 over 6. Now we got f of x is equal to 4 over x, and we need to find a derivative of that. Keep in mind, this is just like saying 4 times x to the negative first. We bring out negative 1 up front, so we get negative 4x, subtract 1 to the exponent, so it'll be negative 2. So it'll be negative 4x to the negative second. Alright, so this is the sum and difference rule for derivatives. If f and g are both differentiable, and you're adding or subtracting them, you just find the derivative individually for each of them. Okay, it's really that simple. Just take the f of x, find the derivative of f of x. G of x, find the derivative of g of x, and then you'll be still adding, subtracting. Okay. Some quick examples. Let's say I have f of x is equal to x to the fourth plus 5x squared minus 7. So I'm doing multiple here at once. So I'm going to do derivative of x to the fourth, which is 4x to the third. Derivative of 5x squared, bring the 2 down. 2 times 5 is 10, 10x. Derivative of negative 7 is 0 because it's constant, as we know by our constant rule that we learned at the beginning of this video. And so your derivative would be 4x to the third plus 10x. Now let's do one more. Let's say we got, let's do some with fractions. We all like fractions, right? Of course you do, yes. So we got negative x to the third over, let's give you 4, plus 2x squared minus 5x. So we bring the 3 down and take 1 away from the exponent, which is 2. It's still negative, don't worry, I didn't forget. All over 4. Plus, bring the 2 down, so it'll be 2 times 2 is 4, which is 4x. And then derivative of negative 5x is negative 5. And here's your answer. I appreciate you watching, and we'll see you later. Bye-bye now.